Okay, physics dorks. Hopefully you are working on your vocab and you're getting to the point where I think you're going to be caught up or whatever else. Because like I said, I want to try and have a quiz on Friday. So just to wrap up really quick, hopefully you got the idea on Ohm's law, knowing that, okay, if you look at Ver, if you increase the resistance, what's going to happen to the current? It's got to slow down. If volts stay the same, let's say you use, if you got 12 volts and your resistance is 4, your current is 3. Okay, 3 times 4 equals 12. Well, if you increase the resistance to 6, what's going to happen to your current? Well, it's got to reduce to 2, so 2 times 6 equals 12. And that's exactly what happened. Hopefully you saw that near the lab. Come on, admit, that lab was actually kind of cool, the little doodad. That was really neat. But anyway, that's hopefully the idea behind Ohm's law. Now, what we can do with that, to wrap up the unit, if you look at something known as power. Oh, darn it, why doesn't that fit in this stupid thing? There we go. Power. Now, as it says there, it's the energy per unit of time, heat or light, but it's energy given off. So like a light bulb, it could be, your heating unit on top of your stove or whatever else. The idea is that, I got a call coming in, and I'm not going to answer that. No, not doing it. So the idea is that we can use this current to create power. Now, power, what you end up having here is you've got the equation, you can see right here, that it is volts times current. So it's joules per coulomb times coulombs per second, which if you do your, canceling out, it gives you a joule per second, which is a watt. And 1,000 watts in 3,600 seconds is 1 kilowatt hour. So the idea, now hopefully you've heard of watts before, or kilowatts. That's the idea of how they sell you electricity, because, it's all about the power that you actually use and how much you actually heat this up, how many volts and how much current you're actually using at your house. Now, the cool thing about this is that anything that's a resistor, now a resistor could be literally anything, kids. A wire running through your house is quite literally a resistor. Your toaster, the electricity trying to go through that, the little wires in your toaster, they resist the flow of electricity, so they're resistors. Light bulbs, they're resistors. They resist the flow of electricity. All of them obey Ohm's law, Ver. And so if we look here, we can see we've got power. We got volts, we got current. Okay, volts, we got amps. All right. Well, instead of putting in a V, we've done this all before. V, it can equal, Ohm's law. I could put in IR. So if I put in IR instead of V, which is IR and V they're equal to each other, I can then end up with something called I squared R. Now, if you now look at this and take a look at what power actually really is, it's the current squared times the resistance. So what does that tell you, kids? If you increase the current, what happens to the amount of power that happens with, with your system? You increase the current, your power increases exponentially. It's crazy. Okay. So as we said, current is what kills, because the more power you have, the more work you can do with it. Oh God, it just gets ugly. That's why, you watch that video or the movie I told you to watch called The Current Wars, that newer one. Guess what they invented to do with current? Well, they invented trying to come up with a humane way to kill somebody in an electric chair for execution. Didn't work out so well in the movie. And the other one to watch, I'll show you clips of it. Oh, you shouldn't even watch it. The Green Mile. In The Green Mile, where they try and execute the guy with electricity, look at what power can do. I mean, it's crazy. So watch that clip. I shouldn't say watch that clip because it's a little morbid. But anyway, they go through what current can actually do. Now, what you can do with this one is, because if you increase this current rapidly and make it go through a small resistor, or even a large resistor, you make it go through, is that you get all this power given off. Well, it's real simple. See the coils right here? That's the top of your stove. What's running through that? What that is you've got electricity in little coils going through there, and it's wrapped in like a porcelain material, so that's why you don't get electrocuted. But that's why it gets so red hot, because that current is flying through that little resistor, getting cherry red. Now, if you cracked it open and stuck a knife on it, yeah, you'd probably get killed. Don't do it. And same thing here with the toaster. What are you never, ever, ever supposed to do? put a fork in the toaster, a knife in the toaster to get your toast out when it's plugged in. Don't be an idiot, because those are not coated, and that current is going through those wires with such high, so much current is going through those resistors that it gives off so much power that it burns your toast. Okay, and then you dig it out with a knife and get a shock. Okay, same thing watching that old movie Groundhog Day where he dropped the toaster in the bathtub with him, because raw current is going through the toaster and giving off all that power, all that heat. Your hairdryer, same darn thing. All there are coils inside of there. They do this. There's massive current going through. And what's really kind of cool, guess what your switch does? Or your toaster, or your oven, is every one of those you actually turn a dial, and guess what it reduces or increases? It doesn't change the resistance. It changes the current. So the current is changed, and it goes through at different rates, giving off different power. So we got high setting, low setting. This is where you're going to nuke your food really bad because it's red hot. So you get different settings because of the current. Okay. Now the problems with that one. All right. And this is we're going to get to this more or less on the next unit. Okay. So you get the power plant up in Portage that's running electricity. They're making, oh my God, what is that? How many megawatts? They're gigantic. Well, you got to have current at your house, right? Well, if you ran current through those electrical lines all the way from Portage, all the way to your house, or all the way to, Cardinal Glass and Spring Green or whatever else, it would need massive amounts of electricity. What would happen to the electrical wires? They'd get cherry red, and you'd lose all that power on the way there. You could actually see the heat coming off in the wintertime. So that's what they call I squared R loss, is that the whole idea is you want to have low current and really high volts, because the volts, it isn't actually moving electricity. It's the potential of it. So here's where, again, the movie, The Current Wars, Thomas Edison, he wanted direct current. Direct current means the current has to flow from one place to the next, go there and come back. Well, you do that. And why they had a massive fight over this, because it works great in a huge city like New York City. That's where Edison was working in. And they could have a power plant every couple of blocks. It was not a big deal, because then you could have the current run from one place to the next. So the problem is, hey, the rest of the country runs electricity. So if you ran direct current through the entire country, they'd have to put a power plant in Black Earth, in Cross Plains, in Middleton. There'd have to be a power plant everywhere. So that's why Nikola Tesla was working, and that's why Westinghouse together, they were working with the idea of coming up with alternating current. Now, the idea is with that is that you have a massive amount of voltage, and the massive amount of voltage is then separated, and it gives that separation across the wire. It doesn't really actually have the current flow per se. It's not really true how it works, but you got really high voltage and low current. So you got very high voltage, but then at your place of work or your place of residence or your business or industry, there you've got the massive amount of voltage. So now you got a separation. What can you make flow through the wires at your place? If you've got one terminal that's, 220 volts and the other one is 0 at your place, you can make the current run in a circle at your place. So the idea is that they use massive amounts of voltage with low current with AC generating stations, and that's what they do. And so the next unit, we're going to talk about how this kind of works here, where they the different types of volts. Here you got 765,000 volts, 138,000 volts. Your house has 120 volts or 240 volts. So the idea, we got this massive voltage and the current flows through here at your place. Okay. And that's kind of the whole, the idea works. Well, anyway, that kind of wraps up the unit. We're going to have a short quiz on this on Friday. And the last unit's going to talk about series and parallel circuits, of how we actually now apply this stuff. We'll talk a little bit about AC/DC, and then we'll kind of wrap up with that. Okay? Hopefully it makes sense. Hopefully you get your vocab done. But let me know if you got any questions. Okay? Later.